All right, so I'm going to do the review questions for you real quick. I posted these answers and all the filled out work on Google Classroom already, so I am going to go through this really, really quick. All right, so when we have this, remember there's three problems that we're going to need to solve. One is by using the square root. So first thing you need to do is isolate your x squared. And once you isolate your x squared or your variable squared, you just take the square root of it. What you do to one side, you have to do to the other. And x is then equal to plus or minus 3. So remember, because positive 3 squared is equal to 9 and negative 3 squared is equal to 9, that means that when we're saying what number squared is equal to 9, that this can be both a positive 3 and a negative 3. We could also, just to show you how this works, if we subtract over 9 instead of equal to 0, and if we factor this, it factors to x plus 3 and x minus 3. And if we set it equal to 0, then both x is equal to negative 3 or positive 3. So whenever we're doing square roots, we need to make sure that we are putting both a plus and a minus 3 because it generates two answers for us. All right, so now for this problem, same thing, we need to isolate our variable that's being squared. The directions will say solve by taking the square root. So we divide by negative 8, divide by negative 8. And then we get v squared is equal to positive, 2, 5. And then we need to go ahead and take the square root to get rid of our square. So we take the square root, v is equal to plus or minus 5, right? Just because you see a negative sign here does not mean that the answer is no real solutions, because you need to isolate your variable first. As you see, we do get two solutions. If we were to have, and I'm saying if, so I'm creating this, if we did have v squared is equal to negative 25, once you get down to where you're about to take your square root, and if you take the square root of a negative number, you can't right now, so then it will be no real solutions. So do not say no real solutions just because it's set equal to a negative number. It would be no real solutions if you can't take the square root of it. All right, so this is a problem that we did in class in the beginning today. So we need to isolate our variable. So we're going to add over the 6. So then we get 9n squared is equal to 729. Then we will go ahead and divide each side by 9. So then we get n squared is equal to 81. And then we're going to go ahead and take the square root. So that means n is equal to plus or minus 9. All right, so now we have 81p squared plus 5 is equal to 69. So we will subtract over the 5. And now we'll get 81p squared is equal to 64. Now we're going to go ahead and isolate our variable. So we need to divide by 81. And what we do to one side, we have to do to the other. So it's going to be p squared is equal to 64 over 81. And now we need to go ahead and take the square root of each side. So now we get our p is equal to, now remember, this is something that we did in chapter 2. When we're taking the square root of a fraction, we can take the square root of the numerator and the square root of the denominator separately. So the square root of 64 is 8. The square root of 81 is 9. So our answer is p is equal to plus or minus 8 over 9. All right, the next problem, 25x squared plus 2 is equal to 3. So first we need to go ahead and subtract the 2, isolate our variable, and then we need to go ahead and divide it by 25. Then we get x squared is equal to 1 over 25. Take the square root of each. So then we get x is equal to plus or minus the square root of 1 is 1. The square root of 25 is 5. All right, that is it for this section of solving using a square root. Now on to the next section. All right, so for this problem, it was a really, really easy one. All I wanted you to do is think about if we're multiplying two numbers that equal to 0, then we need to go ahead and set our two factors equal to 0, because the only way two numbers can multiply and be 0 is if one of them is 0. So if at least one of them, if one or the other one is 0. So a plus 7 is equal to 0, so we subtract our 7, so then we know a is equal to negative 7. And then we have 4a plus 3 is equal to 0. So we will subtract our 3, so 4a is equal to negative 3. Divide each side by 4. So then we get, or a is equal to negative 3/4. All right, so this one you didn't really have to do any work to it except for just setting it to equal to 0 and solving. All right, now remember, the directions are saying solve by factoring. So if you go ahead and you try to complete the square for this one, you will lose points. Right? Read the directions, follow the directions. And when we're solving by factoring, we need to set it equal to 0. All right, so even if there were another m squared over here or m anything, You just need to move it all over to one side and set it equal to 0. So we need to then add over this 49 to both sides. So then we get m squared minus 14m plus 49 is equal to 0. Right, then we're going to go ahead and use the x method. So 1 times 49 is 49, negative 14. Numbers that multiply to 49 and add to 14, or negative 14, or negative 7 and negative 7. We divide by the 1 that's here. So then we will get m minus 7 times m minus 7 is equal to 0. And since they're both the same factor, m minus 7, we only have to write it one time, but we solve m minus 7 is equal to 0. We will then add over our 7, and we will get m is equal to positive 7. All right, for this one we did in class, so I'm going to really go through this one quickly. So first we do, because we're factoring, and it's already set equal to 0 for us, we're going to take out our GCF. Our GCF is 2, so it's r squared minus 6r minus 7 is equal to 0. We will go ahead then and divide by 2 to get rid of that 2 out front. 0 divided by 2 is 0, so then we will have r squared minus 6r minus 7 is equal to 0. We did this in class, so I'm just going to go ahead and give the answer. So it's r minus 7 times r plus 1 is equal to 0. So we will then set r minus 7 is equal to 0, or r plus 1 is equal to 0. So r is equal to 7, or r is equal to negative 1. All right, we did this one in class. That's why I went through it really fast. All right, remember, when we're factoring, we need to set it equal to 0. So this is not set equal to 0. And we also want our m squared or x squared or variable squared to be positive. So that means I'm going to move these two over to the left, so that way my m squared remains positive. So I will get 3m squared plus 4m plus 1 is equal to 0. All right, I'm going to go ahead and use the x method. So 3 times 1 will give me 3. So numbers that multiply to 3 and add up to 4 are 3 and 1. And now we need to divide by this 3. 3 over 3 reduces to 1 over 1. So then this will factor out to m plus 1 times 3m plus 1. And then we need to go ahead and set it equal to 0. Since it's two factors, multiply to be 0. So that means m plus 1 has to be equal to 0, or 3m plus 1 has to be equal to 0. So we can then go ahead and subtract over this 1. So we can get m is equal to negative 1. And then we can subtract over this 1. So 3m is equal to negative 1. Divide each side by 3. Or m is equal to negative 1/3. All right, same thing. We want to set it equal to 0. We want our k squared to be positive. So we are just going to add over this 41. So I will then get 7k squared plus, add over this 41k. This should be 41k. So plus 41k minus 6 is equal to 0. Remember, we want this in standard form. Ax squared plus bx plus c is equal to 0. So you cannot put this 41k on the outside, or else you might mess up factoring. All right, then we're going to go ahead and draw our x. 7 times negative 6 is negative 42, and this is positive 41. So we're looking for numbers that multiply to negative 42 and add to 41, so that will then be negative 1 and positive 42. Divide each number by 7, because 7 is here. And this reduces to 6 over 1. So our factors to 7k minus 1 times k plus 6 is equal to 0. So then we set each factor equal to 0. So 7k minus 1. So let me just write that a little bit clearer. 7k minus 1 is equal to 0, or k plus 6 is equal to 0. So then we will add over the 1. 7k is equal to 1. Divide each side by 7, so k is equal to 1/7. Or subtract our 6 from both sides. This is a 0. Or k is equal to negative 6. All right, that is it for this section. And now one last section, completing the square. All right, remember, when we are completing the square, now I put the notes, I wrote it out for when a is 1 or when a is not equal to 1, so the number in front of x squared. They're on your Google Classroom, so please, if you're not sure about the steps, just go on your Google Classroom and you can find them there. All right, so when we're solving for completing the square, though, we're setting it equal to our constant. So the directions will tell you to complete the square. So that means we need to move this over to the other side. All right, so v squared plus 4v is equal to 73. All right, then we need to go ahead and we need to take our b. So whatever b is, in this case is 4, You take your b, you divide it by 2, that's 2, and then you square it, that's 4. And that number gets added to both sides of our equation. So now we have v squared plus 4v plus 4 is equal to 77. All right, now we're going to go ahead and factor this out. Remember, once we're completing the square so that we will get a trinomial that we can factor, and it's always going to factor to a binomial square. Whatever your variable is, you put your variable as a linear variable, so not v squared, but just v. And then whatever number you got after you divide it by 2, so we did 4 divided by 2, that gave me 2. That is the number that we will always put into our binomial. And then whatever sign we have here is a sign that we use. So it's v plus 2 squared is equal to 77. Then we're going to go ahead and take the square root of each side. So we get v plus 2 is equal to plus or minus the square root of 77. And then we just need to isolate that v, so we'll subtract 2. So v is equal to negative 2 plus or minus the square root of 77. All right, I do want to see you put your radical last. I don't want to see you write it like this tomorrow. I want you to put the number out front, the constant out front, or the number out front, and the radical second. All right, so once again, the directions will say completing the squares. So we need to set it equal to the constant. So then we get x squared plus 20x is equal to negative 29. So remember, just because it's equal to a negative 29 now does not mean, well, there's no solution. You have to wait until you're about to take the square root. So we take our b, and our b is the 20. So we take our b, we divide it by 2, that is 10, we square it, and that's 100. So we are adding 100 to both sides. So then we will get x squared plus 20x plus 100 is equal to 71. Now remember, we're now going to factor this out. It will be a binomial squared. The variable just gets written without the square. The number that we had when we were dividing by 2, so we got 10, that is the number that we write here. And whatever sign we have in front of our b is the sign that we use. So it's x plus 10 squared is equal to 71. Now, if this was equal to a negative 71, then you could stop and say no real solution. But we can take the square root of that. So it'll be x plus 10 is equal to plus or minus the square root of 71. And now our last part is just subtracting out our 10, and we will then get our final answer. X is equal to negative 10 plus or minus the square root of 71. All right, remember, we are completing the square, so we need to set it equal to our constant. So we're add over our 69. So we get 9x squared plus 18x is equal to 69. And now, since this equation has an a or a coefficient in front of our x squared that's other than 1, we need to factor that out. So we factor out the 9. We're left with x squared plus 2x is equal to 69. Then we will divide each side by 9. So this cancels, and now we're left with x squared plus 2x is equal to 69 over 9. Now, I wouldn't, if you notice that one of these two numbers is a perfect square, actually, if you notice that the denominator is a perfect square, I wouldn't simplify this just yet. Leave it like it is now. Right? Then we will take our b, which is 2, divided by 2, so that's 1. We will square it, that's 1 still, and we will add that 1 to both sides. All right, so now we have 69 over 9 plus 1. So in order for us to add this, we need to get common denominators. So we'll multiply this by 9 over 9. So it's 69 over 9 plus 9 over 9. So that is equal to 78 over 9. So we have x squared plus 2x plus 1 is equal to 78 over 9. All right, now we will go ahead and factor this out. So we know it factors out to a binomial squared, so it would be x. The number we got when we divided by 2 was 1, so it's 1. This is a positive, so it's x plus 1 squared is equal to 78 over 9. Then we will take the square root of each side. X plus 1 is equal to plus or minus the square root of 78. And the square root of 9 is 3, so we can leave it like that. And then our last step would be to subtract the 1. So now we have x is equal to negative 1 plus or minus the square root of 78 over 3. Now, since we kind of did go through this pretty quickly and we missed some time because I was absent after our winter break. If you do this as your final answer, this would be acceptable. However, if you notice, the back of your answer key would have something differently because they were rewriting this as one fraction. So they were writing this as -3/3 plus or minus the square root of 78/3. And then they were going ahead and combining this into one fraction so that they would get x is equal to -3 plus or minus square root of 78 over top of 3. I would accept either one of those as an answer, this written in black here or this written in black here. All right, so this one's very similar to what we just did, except for now we have a 55. That's the only difference between the problems. So I'm going to go through this pretty quickly. We have add over a 55, so we set it equal to 55. Then we're going to factor out the 9 like we did before, so we would get k squared plus 2k. And then we're going to go ahead and divide each side by that 9. So we get k squared plus 2k is equal to 55 over 9. Remember, if this is a perfect square, go ahead and leave it like that, please. Then we take our b, we divide it by 2, so it's 1. We square it, it's still 1. We're adding that to both sides. So when we add this 55 over 9 plus 1, we know it's going to be common denominator, so it's 9 over 9, just like it was for the other problem. So now it's 64 over 9. All right, then we're going to go ahead and have factor this out. And this is going to factor just like the one before. It'll be k plus 1 squared because this k squared factors out to k. The number we got when we divided by 2 is 1. And now it's equal to 64 over 9. So now we're going to go ahead and take the square root of each side. So now we have k plus 1 is equal to plus or minus. The square root of 64 is 8. The square root of 9 is 3. All right? And then our last step that we need to do is subtract over this 1. So we get k is equal to plus or minus 8 over 3 minus 1. Now, if you have numbers without radicals, you do need to combine these. So if you left your answer like this, you will not get full credit. So when we have this plus or minus, that means k is equal to 8 over 3, a positive 8 over 3 minus 1, or k is equal to the negative 8 over 3 minus 1. So we need common denominators for both, so we would have to multiply it by 3 over 3 for both of these. So we get k is equal to 8 over 3 minus 3 over 3, so k is equal to 5 over 3. Here we would have k is equal to negative 8 over 3 minus 3 over 3, or k is equal to negative 11/3. All right, so for this one here, remember we needed to set it equal to the constant, so the only one that we're going to move over to the left side is this negative 19x. We're going to leave the negative 30 on this side. So I'm going to go ahead and add over this 19x because we want our constant all by itself. So x squared plus 19x is equal to negative 30. Let me go ahead and just rewrite this so I give myself space. Is equal to negative 30. All right, then we're going to go ahead and take that middle number. We will divide it by 2. And since this can't be divided by 2, we leave it as a fraction, and 19, and then we're going to go ahead and square it. So 19 squared is 361, so it's 361. 2 squared is 4. So we plus 361 over top of 4. So now we're going to go ahead and add these fractions. So negative 30 plus 361 over 4. Well, we need a common denominator, so we will multiply this by 4 over 4. So we'll get negative 120 over 4 plus 361 over 4. And this is going to be equal to 241 over top of 4. All right, now we're going to go ahead and factor this out. Well, let me just write this out next. So we will get x squared plus 19x plus 361 over 4 is equal to 241 over 4. All right, now we need to go ahead and factor this out. Remember, it's always going to be a binomial square. Whatever a variable is gets written here, and whatever we got when we divided that b by 2 is what we write here. So since it was 19 over 2, it just remains 19 over 2. This is positive, so this is positive. So it's equal to 241 over top of 4. All right, now we will go ahead and we will take the square root of both sides. So we have x plus 19 over 2 is equal to plus or minus the square root of 241 over top of 2, because we can take the square root of 4. And now we're going to go ahead and subtract over a 19 over 2. And since these are common denominators, we can write this in one fraction. So you will have to write this, since it's already given to you in common denominators, you'll have to write it in like fractions. So it'll be minus 19 because we want our number first, not the radical. And then plus or minus the square root of 241 over top of 2. And that'll be your final answer. One more question, that's it for this video. All right, so we're going to solve this by completing the squares. So we need to, since it's already set equal to our constant for us, we need to factor out this a because we want our number in front of our variable square to be 1. So it'll be 4 times m squared minus 3m is equal to 10. And then we will go ahead and divide each side by 4. And remember, I said if our denominator is going to be a perfect square, I would prefer that you don't simplify right away and leave it like this because it'll actually give you your right answer quicker. So it's then going to be equal to 10 over 4. We will then take this 3, divide it by 2. It can't be divided by 2, so it stays as is. Now we square root of 3, which is 9. We square root of 2, which is 4. So we're adding 9 over 4 to both sides. And now this actually allows for us to right away to combine our like terms. So we will have m squared minus 3m plus 9 over 4 is equal to 19 over 4. And now we're going to go ahead and factor out. So this will factor out to m. Remember, it's a binomial squared, whatever we get when we divide by 2, so it's 3 halves. And since this is a minus, so it's m minus 3 halves is equal to 19 over 4. Then we take the square root of each side. So we get m minus 3 halves is equal to plus or minus the square root of 19 over top of 2, because we can take that square root. Now we're going to go ahead and add 3 halves to both sides. And since they're the same denominator, we can just combine them. So m is equal to 3 plus or minus the square root of 19 over 2. Final answer. That is it for this video.